All right, with all that boring school stuff out of the way, let's talk about poker. I don't really know if you're that excited about it, but anyway, um, poker probabilities are kind of a thing that actually often crops up. I believe there's a homework problem or two that talks about them. And a lot of the examples I've drawn, I'll be perfectly honest. I first came up with them when I was fresh out of graduate school, and at that point, like poker tournaments were like the big thing. You couldn't change from one TV station to another without stumbling across somebody's poker tournament show because it was like the in thing. All right, so I'm not delving in too deeply into a lot of the stuff here. Don't panic that you suddenly need to learn a whole lot of poker language or anything like that. But I want to take a look at a couple of examples of different types of poker hands and how likely you are to draw one. Okay, so on the first front, we're going to talk about something called a flush, kind of like the craps thing. It's a bit of an unfortunate name. Anyway, so a flush consists of 5 cards that are all the same suit. So either hearts or diamonds, clubs, spades. I've covered them all now. I was getting ready to say you get the idea, but anyway. So I want to see exactly how likely it is that you draw a flush with a 5-card poker hand. So standard 52-card deck, no jokers. All right, so when I normally take a look at one of these guys, I kind of set the stage for my students. Imagine that you're watching like a Western, and you see, a couple of, cowboy types sitting around a table in a saloon playing poker. And, they've done all of their betting and, whatnot. And finally, one guy at the table says, I got a flush, and, puts his cards on the table. Then another player at the table does the same, so do I! And they put down their hand, and it turns out they both have a flush. The question I would usually ask my students is, how might the two cowboys' hands look different? So there's 2 main ways I can see. It's possible they have different suits of cards, right? Maybe one has a flush that's all spades, the other one is all diamonds. So I'm going to kind of label this up top like we're doing a counting principle thing and then just slap it over, the denominator we need for a probability. So the suits could be the same, or it could be different rather. And even within the same suit, it's technically possible, although astronomically unlikely, that they both have a flush with the same suit. They could both have hearts, right? Because there's 13 values, and 2 5-card hands only takes up 10 cards. So the values within a given suit could also be different. All right, now let's work out what's going on with each of these things separately. Okay, how many different suits are possible for them to choose? There's only 4, right? I've already laid them out. Feel free to rewind if you need them. If you'd written 4C1, that's fine. Again, gives you 4. This one requires a little more legwork. So in values, I've already said there's 13 of them. So 2 through 10, the 3 face cards and the ace. So we have 13 values. If all 5 of our cards are of the same suit, we got to pick out 5 of these 13. I'm going to put a C right here. For the record, order doesn't matter. If you've ever watched people who are really serious about poker playing, they do not move the cards in their hand. They are terrified of giving somebody information. I mean, to be honest, if a poker player moves the cards in their hand, it's probably a lie. So, anyway, and like we saw with our example with the students in the project, I'm going to need to multiply those 2 guys together in order to work out, the total numerator of this thing. All right, down below, we want the total number of possible 5-card poker hands that we're going to be dealt. So there's 52 cards in the deck. I said no jokers. Forget those guys. We hate those guys. We're picking out 5 of them. And like I said, the order doesn't make a difference here. So 52C5 down below. All right. So for what it's worth, up top, 13C5 should work out to be 1,287. So you multiply those 2 guys together, you got your numerator. The denominator is a little more intimidating because, that you might not be surprised. There's a lot of different poker hands possible. So I got 2,598,960. So This is not, again, not exactly a fraction that rolls off the tongue. Feel free to come up with one, but I would totally understand if you go into decimal approximation land. I got 198. So even moving the decimal point a couple of times to make a percentage, we're looking at a less than 1% chance for delta flush. So that's where I'm going to call, that particular example. One thing I do want to point out, in case you are a poker shark, technically, yeah, this number is a little high because I haven't pulled out straight flushes or the elusive royal flush. Feel free to play around with that, but for the purposes of finite mathematics, I think we're okay just saying, those guys are still flushes. Call it a day. All right. One poker hand down. I got one more I want to take a look at, and then I will set you loose on some unsuspecting homework. All right. So, the other example I want to take a look at is a full house. So, again, don't panic if you're not familiar with poker terminology. It's okay. A full house consists of 3 cards of one value and a pair of cards of a different value. So, like 3 8s and a pair of 2s. Or 3 kings, a pair of aces. Make sense? Okay. So it's a little trickier to play the cowboy western game with this. You can still look at it though in terms of how might 2 people have a full house, but have them be different at the table. So the denominator is still 52C5. So I'll go ahead and fill that in because we worked that out. And if you just wanted to write in the 2.5 million thing, also fine. So this time around, we need to rearrange stuff. So their values might be different. Somebody might have, like I said, 8s, and 2s as opposed to, kings and aces or something like that. Now, from there, they could have, possibly the same values, but the suits could end up being different. Or, this is for the set of 3. Now, again, this is where the Western analogy breaks down, because if 2 people at the same poker table with one deck of cards both say they have 3 aces in their hands, if it's a Western, somebody's probably either going to get shot or punched. Anyway, but that's a way they could be different. The pair suits could also end up being different here. So again, remember, we've got 4 suits possible for the set of 3, 4 suits possible for the pair. All right. So the values, I actually messed this up in front of a class once, and I was kind of embarrassed about it. This one time, this is like the only time it usually comes up in the context of poker probabilities, the order of cards really matters. We're not necessarily like arranging them in our hands, but the trick is it's not the same poker hand if you have 3 aces and a pair of 2s instead of 3 2s and a pair of aces. Those are 2 different poker hands. So which one is the set of 3, which one is the pair, does make a difference. So that means we need to pick out 2 values from our collection of 13, but the order makes a difference. We want 13P2 here. I will let the cat out of the bag. We need to multiply. Coming on to our sets, now the order doesn't matter. We don't care if you've got the spade to the left in your hand or what. So there's 4 suits. We are picking out 3 of them. For the pair, there are still 4 suits. We are picking out 2 of them, and the order doesn't make a difference as far as suits go. Like I said, this value thing is kind of an odd duck. All right. So now, arithmetic time, or calculator button pressing time, if you prefer. This thing gives me 156. 4C3 should be 4. 4C2 gives me 6. And then the bottom is that big multi-digit abomination from earlier. 2,598,960, assuming I wrote down all my digits right. And I'm pretty sure I did. Okay. So now, what does this end up working out to give us? I got 0.00 again. 144. So that probability smaller. And it's still smaller even if you take out the straight flushes and stuff that I talked about earlier. So in general, if 2 people are playing poker, one says, I got a flush, and then the Mickey Mouse guy says, I got a full house, you know who wins. Because the stronger the poker hand is based on the lower the probability that it comes up. Okay, So we've done a fair number of examples of this, probability with fancy counting technique stuff at this stage. So you should be ready for the homework exercises coming up. As always, let me know if you have any questions. I will see you with some more videos next week, I guess.